Shake Table Lab by Aidan Eliason and Justin-Aidan. On our first day of construction, we worked on our base plate for the beginning of our tower. Making the first story on the second day was to ensure maximum stability. The base plate ties the structure to the ground to prevent shaking. The first story was completed on the third day, starting to work on our second story. The first story is one of the two parts which will hold half of the sandbags. On the fourth day of construction, we worked on cross braces. This helps make the building stay stronger and have less of a back and forth motion. Friday, the fifth day of construction, was a block period, giving us time to finish the top story and put construction paper on the floors to give us more support in holding the sandbags. The slide that you are looking at shows our tower dimensions. The stories have to be at least 18 centimeters tall. Unfortunately, we had no pictures of us testing our tower. However, when we did test our building, our tower held 4 sandbags, 2 on the top and 2 on the bottom. Bye. Countdown. Yeah. We tried using as much tape as we could to make our structure stable. The cross braces also helped to stop the swaying of the tower. Our strongest part was our base and our top crossbars. The base helped support the straws on the corners from bending more, and the crossbars helped stop the swaying. Our weakest parts were both part of the first story, as you can see in this picture. Our first bottom crossbars just couldn't take the weight of the sandbags. The annotations on this picture are pointing at the areas with the most tape used, but overall, we used tape almost everywhere. If we had 5 extra straws, we would use them to support our tower to hold more weight. Come on. Dang it.
Oh, that's not good.
It's gonna be fine for the first one.
The first one's definitely.
These are our sensor readings for the structure on a major earthquake. This is taken on an XYZ scale. The x-axis represents the forward and backward motion. The y-axis represents the tower going side to side. And the z-axis represents the up and down motion.
Bye. Countdown. Yeah.
Okay, so our structure, my name is Aidan Eliason, and my other team member is named Justin-Aidan. And so our building supported about, I think it was 3 sandbags. And our building failed was on the crossbars when we were shaking it back and forth. The 4 straws on the side supporting the structure bent, and it fell backwards, and it fell, yeah. And if I were going to build it over, what I was going to change is we didn't have much of an inward curve, which we might have should have, because a lot of the buildings that had a more inward curve lasted for longer and they had better support. And so, yeah. And what did I learn about buildings, strong earthquake-proof buildings, was that you have to kind of go to triangles for this. Like, crossbars are definitely good, but you also want to curve inward. Like I was saying before, that they also help the structure, like, not move and stuff. And what I liked about this was it was kind of cool because you got to have teamwork with your friends, and you had to try to build a structure that would stand like the strongest earthquakes and the most sandbags. We didn't do that, but we still had really fun and we got 100% on our project. And that's all.
Okay, are you now? Okay. Hi, I'm Justin-Aidan and my partner for the Shake Table project was Aidan Eliason. First of all, our earthquake tower held about 7 sandbags. Our building failed at our first story crossbars. If I were to build it over, I would definitely strengthen our bottom crossbars as well as our first story in general. I learned that overlapping your structure makes your earthquake building even stronger. I like this lab because I got to work with a partner, which I'm very good at, and it was just very fun testing out our buildings in general.